Hi students, in this video I'm going to go over how to solve absolute value inequalities. When we solve inequalities, there are going to be four things that can happen, or in this case we refer to them as four cases. You will have a conjunction, a disjunction, no solution, or all real numbers happen. So let's assume that this variable p is a positive number. When the expression of the absolute value is a less than positive number, and when the expression of the absolute value it's less than or equal to a positive number, you will have a conjunction. So that is just saying that you're going to have an answer that's going to have a value and another value as your endpoints, and then you're going to have all the values in between as solutions from those values. If you have equal to, you're going to have a value including that value and another value and including that value and any value in between as solutions. So these are the visual representations of what a conjunction is. So whenever you solve for an inequality that results in this expression, it'll be a conjunction. On the other hand, if we have an absolute value that is greater than a positive number, or an absolute value that is greater than or equal to a positive number, we're going to have a disjunction. A disjunction is when you have an answer choice where you're going to have either a number and anything less of that number, or another number and anything higher than that number. So this is the visual representation of what solutions you can have. You will also have the filled in circle version of this, where you have the solution includes that number itself and anything less, or that number over here itself and anything more. So again, you're either going to have two numbers and anything in between those numbers, or two numbers and anything in opposite directions of those numbers. Conjunction is connected, disjunction is disconnected. For the no solution in all real numbers example, it's when you have an absolute value less than a negative number. So that is just a negative number. Absolute value will never be a negative number, it will always be positive. So this is saying if a positive will be less than a negative. So this is never, that will never be true. So that's how you know no solution is the answer. And in the graph, when you have no solution, it's just a blank graph. When you have all real numbers as an answer, the absolute value will be greater than a negative number. So since the absolute value is always positive, the positive number will always be greater than a negative number. So because it's always, it will be all real numbers. So those are the four things that could happen. The steps to solve are similar to solving equations, but now we do apply the steps of considering switching the sign in certain cases. So whenever you divide or multiply by a negative number, you're going to change the direction of the inequality symbol. Also, whenever you're going through the process of solving, you are still going to isolate an absolute value like you did with equations. But before you split, you need to determine if you're going to have a conjunction, disjunction, no solution, or all real numbers. If you do end up with a conjunction or disjunction, then you do want to continue with step 3. You're going to split the inequality into two separate inequalities. The first one will be the same inequality sign as the original with the positive quantity, and the second will be an inequality sign flipped and a negative quantity. When you write both inequalities, you will then solve for them, and that should give you two answers. And the two answers, again, will either be represented as 2 points with solutions in between, or 2 points with solutions in opposite directions. So that's what it means about graph. Use the number line to graph the inequalities. All right, let's do 3 examples. I'm going to go over the examples of practice since we did go over the examples on the left side in class. So I just want you to have an opportunity to see how to do these. So we're going to ask ourselves if the absolute value is isolated. And right now the absolute value is not isolated because it has that -3 afterwards. So we're going to add 3 to both sides. And then we're going to end up with absolute value 2x plus 1 less than 3. So the sign doesn't change because we did not multiply or divide by a negative. And we're just simply adding the 3 to cancel it on this side. So now, again, we ask ourselves, is the absolute value isolated? In this case, it is. So we will have, again, the 4 scenarios of either a conjunction, disjunction, no solution, or all real numbers. So to decide which case it is, remember that conjunction is when you have less than, disjunction is when you have greater than, no solution is whenever you have a negative number on the right, and also all real numbers is whenever you have a negative number. So we're not going to have these 2 cases in this example. We have a less than 3, which means that we will have a conjunction. So let's go ahead and split it and see what are the 2 values we're going to have. So we're going to write exactly the same expression with the inequality and the number afterwards that we see. And on the second inequality, we're going to write the expression, flip the symbol, and write the negative version of the answer. To solve for this, we're going to now subtract 1 on both sides. And I'll do both at the same time just so we can get them together. So 2x less than 2, and then 2x greater than -4. The next step will be to divide by 2 to get rid of the coefficient of 2. And we're going to divide the other side by 2 as well. Because we did not divide by a negative, we're going to keep the symbol. 2 divided by 2 is 1. And then x, keep the symbol. -4 divided by 2 is -2. So now let's interpret these numbers in the number line. So the number line goes from least to greatest. So the first number we're going to have is -2. And I'm just going to write an endpoint and the other point. Like, they don't have to be in the exact same order based on the dashes. It's just to kind of give you an endpoint on both ends. So this -2 and this will be 1. So -2, it says x is greater than -2. Greater values of -2 are to the right. And then this one says x is less than 1. Values that are less than 1 are to the left. So this creates a conjunction where any value from -2 to 1, but not including -2 or 1, are solutions to this inequality up here. We can always plug in numbers and check. So any number between -2 and 1, for example 0, we can type it in there and see if it's true or false. So I'm going to assign the value of 0 into the letter x, and then I'm going to type this inequality. So absolute value of 2x plus 1 minus 3 less than 0. And I'm going to press enter and it says true. So I can just try different numbers if I need to keep checking, but basically it confirms that because 0 is in between, it is a solution to the inequality. Okay. For the next problem, we're going to have a 10 in the front, -10 in the front. So to isolate the absolute value here, the -10 is multiplying right now. So to get rid of it, we'll divide by -10. Now the absolute value of x plus 1 doesn't change, but the flip, we're going to flip the symbol. We're going to apply the dividing by a negative flips the symbol rule. And then negative 7 divided by negative 10 is positive 7. So now that the absolute value is isolated, we will rewrite this if needed, or just say no solution or all real numbers. So again, the options are conjunction, disjunction, no solution, or all real numbers. And no solution, all real numbers is answers whenever this is a negative. So we're not going to have these. And then the conjunction is whenever you have a less than or equal to. And then disjunction is whenever we have a greater than. In this case, we have a greater than, so most likely it'll be a disjunction. So let's check what those numbers will look like. X plus 1 is greater than or equal to 7, so copy it exactly the way it is. And then x plus 1, flip the symbol, put negative 7. So to solve for this, we're going to subtract 1. And we're going to end up with x is greater than or equal to negative 8. And then over here is x. Oh, actually, this is 6, sorry. 7 minus 1 is 6. And then x is less than or equal to negative 8. So to graph this in the number line, negative 8 will be first in the number line. So I'll write negative 8. And let's say it goes all the way to 6. This is equal to for both of them. So that means both of them are filled in circles. And then x is greater than or equal to 6. So anything greater or equal to 6. And then less than or equal to 8. So anything less than or equal to negative 8. So for example, if I use the 0 here, the 0 is in between, which means it should not be a solution. I'm going to type this in the calculator just to confirm that when x is 0, this is not true. Negative 10. Absolute value of x plus 1. And then less than or equal to negative 70. So that's false. But if I pick a number anything greater than 6, even including 6, it should make it true. So if I put, let's say 7, and I'm going to store it in for x, and I'm going to highlight that, press enter again. So now it says true, because it's a number greater than 6. So again, the calculator can use this to confirm if you did the work correctly by plugging in values that are in the solution area. The last part is this one, and then the absolute value is right here. So this one's not isolated since it has that plus 7 at the end, so I'm going to subtract 7. And now I have absolute value of 8 minus x less than 5 minus 7, which is negative 2. So because we have here an absolute value less than a negative number, we know that it's not a conjunction or a disjunction, but it could be a no solution or a all real numbers. Now, to know which one's which, again, absolute values are always positive. So ask yourself, is a positive less than negative 2? That is nope. That is false. That's never going to be true. The positive will never be less than negative 2. So no solution is the answer here. Okay, I hope these 3 examples help you understand how to solve inequalities.